when we were stacking those small and those large cups, both cups added 1.5 centimeters each time, but they had a different y-intercept, so they were going to be parallel. They were never going to touch, if we think back to what we did yesterday afternoon. So we're going to build on that idea today, and we're going to be looking at solving systems of equations. So our targets for today, I think I literally just talked about them, was I can graph a systems of equations and I can solve a systems of equations using algebra. We're not going to be doing too much actual solving today. We're going to be looking at our graphing today. We're going to be looking at graphs that are already created, and we're going to be interpreting those graphs, okay? So if we look at activity number 1, 14.1, true or false, 2 lines. In your textbook, it looks like this, okay? And it says, use the lines to decide whether each statement is true or false. Be prepared to explain your reasoning using the lines. So you need to look at these 5 statements down here, 1, 2, 3, 4, 5, and these 2 equation lines, and you're going to take 2 minutes right now to decide, are these statements true or false? I want you to take 2 minutes right now to decide, are these statements true or false? You guys can get started. Throw questions in the chat. Oh, did I send this out to you guys with not making a copy of it? I feel like I did. Okay, so what your job is today during our 30 minutes of meeting time is I need every single person to go into the slideshows and make a copy of this for themselves and attach it, because you will be working in these slides today. Okay, we are taking 1.5 more minutes. There we go. So no, only the pieces that in the in the video, I have you do it in the slideshow. So you're gonna be using it really for the second half. I'm gonna have you insert a picture from your work for the first half in there, but this afternoon, and I'll explain it when I get there. Okay, so ladies and gentlemen, let's come back together. I don't know why that didn't go off, but okay. Let's take a look at this activity. So everybody can see my screen. Let's take a look at these lines here. So the solution to 8, ooh, that's weird. 8 equals negative x plus 10 is going to be 2. So that means I need to take this 2 and substitute it in for this variable. It's going to look like 8 is equal to negative 2 plus 10. Negative 2 plus 10 is equal to negative 2 plus 10 is equal to 8. Very good. 8 is equal to 8. Is this a true statement? Let me see some other people in the chat. Yes, very good. This is a true statement. So next to this one, you should write true. Okay? And this work should be copied into your textbook. I'm going to test the next one up here, and then I'm going to erase this guy down here. So make sure this first set gets written in. A solution to 2 equals 2x plus 4 is going to be 8. So that means I need to take that 8 and plug it in for my x and solve. Negative, or no, 2, that's just a 2. 2 is equal to 2 times 8 plus 4. 16 plus 4 is equal to what? $20. Very good. 20 is equal to 2. Is that a true statement or is that false? True or false? Nice job, Elliot. Nice job, Ian. This is a false statement. Very good. This also should be written in your book somewhere as evidence to prove it. Okay? So now it says the solution, a solution to negative x plus 10 equals 2x plus 4 is 8. So that means I need to take 8 and plug it in for both of these x's here. So negative 8 plus 10 is equal to 2 times 8 plus 4. So negative 8 plus 10 equals nice job. It equals 2. 2 is equal to, what's 2 times 8? 2 times 8 is 16. Nice job. Plus 4 is equal to 2 is equal to 20. Is that a true statement? Or is that false? Nice job, Ian. Nice job, Naseem. That is a false statement. Okay? I'm going to leave that. You're going to copy that in if you didn't have it. This was an 8. We're going to look at number 4. Negative x plus 10 is equal to 2x plus 4. And it says a solution to that is 2. So that means I'm going to take 2 and do what with it? What am I going to do with it? I'm going to plug it in for x. Yes, Kyle. Plug it in for both x's here. So negative 2 plus 10 is equal to 2 times 2 plus 4. So negative 2 plus 10 is equal to nice job. It's equal to 8. The left side is equal to 8 is equal to 2 times 2 is 4 plus 4. That simplifies to 8 is equal to. Nice job, Max. Nice job. Awesome job, Ian. Awesome job, Gwen. 8 is equal to 8. Is that a true statement or false? Very good, Max. Very good, Ian. It is a true statement. Very good. Last one we're going to look at. There are no values for x and y that make y equals negative x plus 10 and y equals 2x plus 4 true at the same time. Is that true or false? Number 5. Nice job, Ian. Well, we just found that if I had 2 and I plugged it into both of these equations, John, it made a true statement. So that means there's at least 1 point there. Awesome job, Ian. He said because there is an intersection point. Very good. This is a false statement because the coordinate 2 comma, what was it? Let me look. 2 comma negative, wait, no. 2 comma 8 makes it a true statement. Very good. Nice job, guys. Fantastic. Let's take a look at the next piece of this. Here we go. We're matching some systems of equations. So here we have 3 systems of equations, A, B, C, and they are graphed on a coordinate plane. Your job is to do first, match each figure to one of the systems of equations shown above. So we have these systems of equations over here, and now it's your job to match the graphs with the systems of equations. You're taking 1 minute right now to match the systems of equations with the graphs, okay? Maybe that will actually make a timer noise this time. No, I have a better one here. Here we go. We're taking 2 minutes right now to match those systems of equations with the graphs. Be sure to explain a strategy that you used. Nice job, Max. I'm going to turn the heat down. Sorry, guys. I'm totally kidding. I don't know why I'm saying sorry, because you're not even here. I was just walking away. So we have another minute left to make these choices here. Actually, I'm not going to have you move on to the next number 2 because it is a little bit challenging and I want to do it together. Okay, we're taking about 40 more working seconds, matching these graphs to these systems and being ready to give me a justification for the choice that you made. What did you look at to determine? Nice job, Max. That's a really good reason. Awesome. Throw some answers in the chat. List off the letters that you did in order. So A, lowercase a went with what letter? Lowercase b, lowercase c with which one's up top? Nice job, Gwen. Fantastic. We're taking 6 more seconds and then we're coming back together. Okay, here we go. So let's take a look at lowercase a. Which graph did you match with lowercase a? I want everybody to put it in the chat. Which one did you match with lowercase a? Okay, a lot of people are putting this uppercase A. Okay, so then Max, can you unmute and can you tell me how you made your decision? What strategy did you use here?
I know that those 2 equations match with graph A because for example, for the first problem, you have a y-intercept of 5, and graph A is the only graph that has a line that has a y-intercept of 5. Same thing with 20. It's the only graph that has a y-intercept of 20.
Good. Fantastic, Max. Perfect. One strategy that you could use was you can look at the y-intercepts in these equations, and you can look for the graphs that have those y-intercepts in those locations. Another strategy that you can use is you can look at the types of slopes. Okay, so for example, if you're looking at C here, uppercase C has 2 positive slopes. If you look at that line, it is the only wait, actually, this one also has 2 as well. Or you can look at A and you can say it has a positive and a negative slope. That's how you can make this determination here. Very good. So you can look at the types of slopes and you can look at those y-intercept values. Awesome job. Now I want you to throw in the chat, which one went with lowercase b? Which graph did you match with lowercase b? I want a couple more people, throw it in the chat. Let's see what you got. Okay, what I need is, Gabe, can you unmute and can you tell us how you made that decision of C?
I saw the y-intercepts in the equation and they're on the graph C2.
Fantastic. So he looked at those y-intercepts. Very good job. Nice job, Gabe.
I mean B.
See, oh yes, for systems B. Good. Now let's look at the last one. Let's look at lowercase c. Which one did you match with lowercase c? Throw it in the chat. Cindy, throw it in the chat. Which one did you get? Nice job, Abby. Nice job, Junior. Nice job, Gwen. It was uppercase B, okay? And another way that you can look at is you can look at these slopes for this one. So this one has a slope of 0.5. So that means my line is not going to be very steep. Which one of these graphs here has a line that's not very steep? This guy right here is going to have a line that's not very steep. You could also look at those y-intercept values, okay? Awesome job. Make sure you get these written down. Make sure you write these strategies that you can use down as well in that section. So then now for the next section of this, I'm going to be using the document camera because I'm going to be showing you how to solve systems of equations, okay? So you're writing down these strategies. I'm erasing the first piece of this so that you can still copy down your strategies. On this slide, I linked in a calculator on this link right here. If you wait, let me go back. If you click on that word that says calculator in the slides here, it will open up this Desmos calculator for you. I know you guys have your phones, but I wanted to link it in case you need it, because we will be doing a little bit of a little simple multiplication, addition, subtraction, and division, okay? So if we look at slide number 7 in your textbook, it is the bottom section of this page right here. So I'm actually going to move out of this slideshow. I just said that and then I didn't live it. So let's live it right now. So we are on page number 2, activity number 2, 14.2, graphing a systems, or matching graphs to systems, okay? So what we did here was we made these matches. We said A went with capital A, B went with capital C, C went with capital B. We used y-intercepts and slopes to make our distinctions there, to make our choices. I still have access. Let me just turn the screen a little bit so you can see me. I'm going to be at the document camera. I can see the chat, so please make sure that if you have questions, you're throwing them in the chat as we're going through. Remembering that only I can see the chat. Let me show you how we're going to solve these systems of equations. So we solve systems of equations using a strategy called substitution. And substitution is a fancy way of saying to plug in, okay? And if we look at these equations, we look at them and we see they're all written as y is equal to. So we're going to solve system number 1 by taking the right side here, because we're saying it's equal to y. So we're going to take the right side and we're going to plug it into the first equation for that y. So in your textbook, you're doing this with me. You're separating it into 3 sections. In the A section, we're going to look and we're going to set it equal to one another. Negative 2x plus 20 is equal to the right side of the first one. Okay, because they're both written as y equals, we can set these two pieces equal to one another. Negative 2x plus 20 is equal to 3x plus 5. Does everyone see what I did? And does everyone have it written down in their book? Okay, so now we're going to solve this like we would any other equation. We need to get our x's to one side. We need to get our variables or we have to get our constants to the other side. So if I'm looking at this, what am I going to move here? What am I going to do to each side first? Very good. We're going to add 2x to each side. Very good. Because this 2x, this negative 2x is the smaller of the two variables. So we're going to move it to the other side using the opposite operation. Negative 2x, the opposite of that is plus 2x to each side. When we do that on the right side, on the left side, we're left with 20 is equal to 5x plus 5. Now we need to get our constants over to the right side. How am I going to do that? Very good, Junior. Minus 5 from both sides. Make sure you're following along in your book with me. So then I do my subtraction on my left. 20 minus 5 is equal to 15 is equal to my 5x. How do I isolate my 5 attached to that x? How do I isolate it? Divide, very good. Divide by 5 on both sides. Fantastic. So my x is going to be equal to what number? Very good, Kyle. Very good, Gwen. Very good, Abby. Awesome job, Junior and Ian. It's going to be equal to 3. So I'm trying to find the solution. And solutions are written as coordinates, right, of x, comma, wait, no, I can write it here. Solutions are written as coordinates, right, x, comma, y. So now I need to plug this 3 in and find my y value. So I pick one of my equations. You can pick either one. I'm just going to pick the first one because it's a little bit easier. And I'm going to solve it for y. So I'm going to say y is equal to, and I'm going to plug 3 into the equation. So it's going to be 3 times, instead of x, we're going to plug in that 3. And then I'm going to bring down my constant of plus 5. Does everyone see how I did that? I took the equation here. And instead of having an x, I plugged in that x value that we calculated. And now I'm going to solve it for y. So what is 3 times 3? Very good. It's going to be 9. And then to that, I'm going to add 5. It's going to be equal to y. Y is going to be equal to what number? Very good, Junior. Nice job, Ian and Peyton. Fantastic. Y is going to be equal to 14. So my final solution is going to have to be written as an ordered pair, x, comma, y. What was the x value? Write the coordinate in the chat. Nice job, Ian. Don't forget that important piece. You can't really see my hands that well, but you want to write the parentheses around it. Very good. It's going to be 3, comma, 14 is going to be the solution for this systems of equations. Now, what I want you to do is I want you to look at B. I want you to set up, I want you to take 1 minute right now to set up how this equation would look once I substitute in for y. I want you to, in your book for B, write the first step. Don't start solving yet. I want you to set up the first step. Take 1 minute right now. In your textbook, I want you to set it up. How would you write this when I set it equal to one another. Solve it using substitution. Nice job, Gwen. Thank you for writing it in once you did it. Very good. We're gonna take about 15 more working seconds. Fantastic job. Once you get it written down, if you want to type it in the chat, that would be pretty cool. Okay, we're taking 5 more working seconds. Okay, fantastic. So if we were to write it, Ian and Gwen both did it, and they actually wrote it 2 different ways, but it still works. So I'm going to write it the first way that Gwen wrote it. Gwen wrote it as 4x minus 1 is equal to 2x minus 10. Another way that you can write it, you can sort of flip-flop it. You could substitute this one into this equation here. You could write it as 2x minus 10 is equal to 4x minus 1. Both ways mean the same thing, because remember, order does not matter as long as the signs stay together. Okay? So now what I want you to do, now that we have it set up, I want you to solve it like we did here for your x. Substitute it into one of the equations. You pick which one, and come up with the y value and write your final ordered pair. I'm giving you 3 minutes right now to do that. To start to solve it for your x, plug in, find your y, write your coordinate. Take 3 minutes right now. If you finish early, I want you to start to think about and write down C. In this one, this x, you can write it as a decimal because it is a terminating decimal. Take a look at those numbers though, Gwen. -9. Oh, very good. Okay, we're taking 1 more working minute and then we're coming back together. Once again, if you finish early with B, start to look at and set up C for yourself. Awesome job, Gabe and Peyton. Fantastic. Fantastic job, Junior. Okay, we're taking 10 more working seconds, 10 more working seconds. Okay, here we go. So I'm starting at the beginning and I'm working through how I solve this. Check back on your Zoom screen. Here we go. So because this 2x was the smaller of our two variables here, I subtracted the 2x from each side. I was left with 2x minus 1 equals negative 10. Okay, so then I need to isolate or bring my constants to the right side or the opposite side. So I added, because it's a negative 1, so I add 1 to each side. I'm left with 2x is equal to negative 9. To isolate or get this x by itself, to undo this multiplication here, I need to divide each side by 2 to maintain equity, okay? And when I do that, I'm left with just an x is equal to negative 4.5. From there, I need to take this negative 4.5 and you pick either of the equations. I just picked the first one because like literally it was the first one on the list. And I plug that negative 4.5 in for x. So y is equal to 2 times negative 4.5 minus 10. Y is equal to, when I multiply negative 9 minus 10, y is equal to negative 19. How do I write this ordered pair for the solution to these two equations? Some people already wrote it, fantastic, you don't need to write it again, but I want a couple other people to tell me, how do I write this ordered pair as a solution? Ava, Cindy, let's see, Cam, throw it in, let's see, Abby, did I see yours? No, I didn't see yours yet. Connor, let me see yours. How do I write this ordered pair? Oh, nice job, Junior. Nice job, Sadie, fantastic. I write it x comma y, x comma y. That's not negative y, it's just a y. So then it would be negative 4.5. I don't know why I didn't finish that 4.5, comma, negative 19. Now, I want you to set up and solve C. I am going to be doing it on my paper here, but I want you to so look away from the Zoom screen, and I want you to, in your textbook, solve C. Solve that systems of equations, find the ordered pair. All of it on your own. You got this. Go ahead, guys. So this example here is the reason that I linked in the calculator. So go back into the slideshow to go to that calculator if you do not have one handy. Mr. Main, you got this, kiddo. Oh, I didn't even start the timer. I'm giving you 1 more minute. Nice job, Gwen. Okay, here we go. Let's come back together. Let's take a look here. So I started off by setting them equal to one another because they're both written as y is equal to. When you have a systems of equations, only when you have a systems of equations, when you have one letter, like one variable is equal to another equation, is when you can use that substitution, okay? So it's 0.5x plus 12 equals 2x plus 27. I subtracted the 0.5x from each side because that is a smaller number. I got 12 is equal to 1.5x plus 27. I had to cancel out and bring my constants over to the left side, so I subtracted 27 from each side. Negative 15 is equal to 1.5x. Cancel out or isolate my x here. Divide by 1.5 on each side. I use my calculator to solve that. If I did not know, negative 15 divided by 1.5 gets me negative 10 is equal to x. And then we had to choose the equation. So like normally I was just choosing the first one. Then I said to myself, I don't want to deal with this decimal. So I actually plugged it into the second one. That was a little bit easier for me to solve. That's just me as like Mr. Main. So I plugged it in and I got 2 times negative 10 plus 27 is equal to y. Negative 20 plus 27 is equal to 7. And I wrote it as an ordered pair of negative 10, comma 7. Okay, ladies and gentlemen? So once again, this video today, I'm saying, okay, so I've decided. I know I've been saying this every single day, but today, I'm not kidding you, here to the end, this lesson today is the most important that you're going to watch in the second half of the day. I'm telling you right now, hand to God, not kidding, most important lesson. So you need to go through this second activity independently at home today, and you need to complete them on the slides. So today, the lesson that you're going to be working on in the afternoon needs to be completed in the slides. So please do not do it in your textbook, do it in the slides. In that slideshow, I need you to make a copy of this slideshow and attach it to the assignment for today. Attach your copy of the slideshow to the one for today. Does everyone understand what I'm asking you to do? Okay. There is no homework this evening other than this activity because it is so important. Okay. Awesome. So please, you guys can head out. If you have any questions for me, please, you can throw them in the chat or you can reach out to me through email this afternoon. Have a fantastic weekend. I will see you all on Monday. Please make sure you watch our video. Bye, guys. Don't you want us to do? You just are doing the second activity. And then there's one slide. So it's, let me pull it up here. 1 second, Gabe. So on here, you need to, from this activity that we did, the first activity, you need to insert a picture of your work from this solving. So the picture of, like, for example, like all of my work here, you need to take a picture of your textbook so I can see your work. Insert that here, so number 8, and then from 10 all the way to the end, you need to do.
Mr. Main, I meant, which don't you want us to do in our notebook?
Oh, so this just the second activity you're not doing in your notebook. You're doing it on the slides.
Okay,
The activity, the one that's called different types of systems. So 14.3. Okay. Awesome job, guys. I will see you on Monday. Reach out if you have any questions at all. I know that Gabe is not scared to do that. You're good. Awesome job, Gabe. Have a good one.